Alright guys, this is day 2 of quadratic formula, so we started messing with this formula yesterday. Just a quick review of what that looks like. Quadratic formula is used first of all when we're finding roots, when we're finding where it crosses the x-axis. So it looks like x equals negative b plus or minus square root of b squared minus 4 times a times c over 2a. And just a reminder that you can find these values, a, b, and c, from your function. A is always the number in front of the x squared term. B is always the number in front of the x term, or the term that has one singular x. And then c is always the term that's by itself. Alright, so we've got that quadratic formula. So what I want to do today is we're going to extend this a little bit. And you saw one of these on your homework, so we're going to talk a little bit more about this. So I've got this function. I want to find the roots just like we have done before. The first thing that we always try to do is factor it. And then the second thing is quadratic formula if it's not factorable. But first we want to look at what happens graphically with these particular functions that are a little bit weird maybe when you first see them. So if I want to graph this thing, I want to find the vertex first. So again, we're just kind of getting an idea of what this thing looks like graphically. Finding the vertex, I've got x equals, and this is negative b over 2a. So I'm going to try to find the vertex of this thing. B is negative 2, so I want the opposite of that. So I get a positive 2 over 2 times 1, which is just 2. So the x value of my vertex, or the x coordinate of my vertex, is 1. Take this number and plug it back in for x, and we can find the y coordinate of the vertex. So y equals 1 squared minus 2 times 1 plus 4. And my y coordinate looks like it's going to be 1 minus 2 plus 4, so that looks like 3. So my vertex is going to be at 1 to the right and 3 up. Here's my vertex. The next thing that's pretty easy to find when these things are in standard form is the y-intercept. It's just given by this number. It's that c value. So my y-intercept, remember that's where it crosses the y-axis. That's a different y value from your vertex, from the y coordinate of your vertex. But my y-intercept is going to be 0, 4. So I go 0, up 4. So my parabola looks something like this. And then it looks exactly the same on the other side. Something like that. So the whole reason that we graph that is to find the roots, or the x-intercepts. And we just want to get a general idea. So we're looking at this parabola. It opens upward. It's above the axis. The question is, where does it cross over the x-axis? And if you look, the x-axis is down here. It never crosses the x-axis. So we can see graphically that there are no x-intercepts here. There are no roots. Alright, so we're going to look at one more that's kind of similar to this. Here's another example. We're going to look at it graphically first, and then we'll show that the algebra kind of confirms what we found graphically. So real quick, I want to find the vertex. My vertex, I use x equals negative b over 2a. So b is negative 6. So I want a 6, a positive 6, over 2 times the a value is the number in front of x squared, so that's negative 1. So that's 6 over negative 2. That gives me a negative 3. For the x value of the x coordinate of my vertex, take that number and plug it back in, and we can find the y value. So negative. And you got to be careful when you plug these in. It's going to be negative 3 squared minus 6 times negative 3 minus 10. That's going to give me my y value. So my y value is going to be equal to negative 3 squared is 9, but then negative on the outside, so that's negative 9, plus 18 minus 10. So this is a negative 9 and a negative 10. That gives me negative 19. Plus 18 gives me a negative 1. So my vertex looks like this. Negative 3, negative 1. There's my vertex. Second thing I want to do is I want to find that y intercept. So this is the y-intercept, or I guess more specifically it's 0, -10. So I go all the way down to -10. There's my y-intercept right there. So this parabola, I'm going to do this as best as I can here. This might be a little bad. But my parabola looks something like this. It was pretty solid. And it looks exactly the same on the other side. So the point here is, let me graph this real quick. Kind of cheat a little bit. There's my parabola. It looks something like that. So the point again here is that we need to find the x-intercepts, or the roots. And if you look on this graph, it makes perfect sense that we don't have any roots. Here's the axis. It's below the axis and it opens downward. So there are no roots, which means there are no x-intercepts. Alright, so let's go through our quadratic formula with these two examples here. We want to find the roots of the x-intercepts. Notice they're the same exact directions here, but we want to do it algebraically this time. So no graph, just do the algebra. And remember, I can find the roots by using that quadratic formula. It'll work every time. The other thing to notice with these is that they're not factorable, and we'll get to that in a second. So p squared minus 4 times a times c over 2a. There's my quadratic formula. That's where I can find the roots. So the first thing I always try to do is factor. Always. And when we factor, that means GCF first. So is there a greatest common factor that I can take out of these? No greatest common factor here, so we're going to look at factors of 4. So that's 1 and 4, and 2 and 2. And we need one of these combinations to give us a difference of 2, or -2 specifically. If you look at these combinations, depending on the sign, I could get a 3 or a 5 out of this one. That doesn't help us. And this one could either give me a 0 or a 4. So neither one of these are going to work. This is not factorable. So because it's not factorable, we're going to use the quadratic formula. And quadratic formula tells me that x is equal to, here a is 1, b is -2, and c is 4. And that just comes from these numbers up here. So I just plug in negative b, meaning the opposite of what b is going to be a -2 or a +2, plus or minus b squared. That's 4 minus 4 times 1 times 4 over 2a, which is just 2 times 1. Go through and simplify. X is equal to, this is going to be 2 plus or minus the square root of 4 minus 4 times 4. So that's 4 minus 16 gives us a -12. And this should kind of sound off alarm bells. So this is what we're talking about, kind of the special case where you get kind of a weird answer. Anytime you take the square root of a negative, means that it does not exist. It can't happen. You're not going to get real values. So my x-intercepts, or my roots, do not exist. There aren't any. And again, graphically, we go back, and this is the exact same problem. And graphically, it makes sense, and the algebra just kind of confirmed that my roots don't exist. All right, so we're going to do the same thing for the second one here, and make sure that we understand how to go through this process. So again, we want to find the roots algebraically. The first thing we're going to try to do is factor. We're looking at this -10. We know that 1 and 10, 2 and 5 are our factors. And there's no way that out of either one of these factors, I'm going to get a -6. And so this is not factorable. So the next thing that we need to do is go ahead and jump to the quadratic formula. Okay? So my a value is given by this number in front of x squared. So my a is actually a negative here. That's -1. B is -6. And c is -10. Coming from right there. So quadratic formula, x equals -b. So that's a +6. And -6 turns into a positive, plus or minus the square root of b squared is going to be -6 squared. So that's a negative times a negative, gives me a +36, minus 4 times A times C all over 2 times A. Go through and simplify. We've got x equals 6 plus or minus. Let's look at what happens inside the square root here. 36 minus is going to give me a negative result. So the negative would give me a positive. But then we have another negative, and a positive times a negative is going to give me a negative. 36 minus 40. 4 times 1 times 10 is 40. So that's a negative 4. And again, alarm bells should be kind of going off in your head. As you look at this square root, it's a square root of a negative. So that means that our answers, or our x-intercepts, are not going to exist. There are no real answers. There are no real number answers that are going to give us this result. So again, we look back at the graph. This is the graph of that thing. And again, graphically it makes sense, and we just kind of confirmed it with the algebra here that the roots do not exist. It's never going to cross over that x-axis.